Welcome back to Arxflix. Today, we're exploring an innovative paper titled Layer Condensed KV Cache for Efficient Inference of Large Language Models. This work addresses a major challenge in deploying large language models, particularly the huge memory consumption associated with key-value (KV) caches in transformers. On the left, you see a standard transformer. On the right, we have the proposed model. Each node represents one layer of a transformer, with horizontal edges indicating how queries are paired with keys and values, KVs. One significant memory consumer in large language models is the KV cache. Traditional approaches to reducing memory consumption focus on compressing the KV cache by reducing the cached sequence length. However, this paper introduces a novel perspective, reducing the number of layers. The idea is simple yet profound. Pair the queries of all layers with the KVs from only the top layer. This approach means that only KVs of the top layer are cached, drastically reducing memory consumption while maintaining performance. Here's a closer look at the proposed model, which caches only the KVs of the top layer. One major challenge with this model is training. In standard transformers, all tokens are processed in parallel. However, the proposed model introduces sequential dependencies, making parallel training difficult. To address this, the paper proposes an approximate training method that supports parallelization. The sequential computation graph. The parallel computation graph. These two graphs are equivalent in terms of training accuracy. Let's talk results. The proposed model delivers up to 32 times larger batch sizes and up to 26 times higher throughput compared to standard transformers. This efficiency is achieved while maintaining competitive performance in both language modeling and downstream tasks. Check out this comparison of throughput. The proposed model significantly outperforms the standard Llama model on an A10 GPU. The method isn't just a standalone solution. It's orthogonal to existing memory-saving techniques, meaning it can be combined with other methods for even greater efficiency. For example, integrating with techniques like streaming can further reduce memory consumption and latency. Here's a comparison of latency per token and memory consumption of streaming versus the integrated model. To sum up, the layer condensed KV cache method significantly reduces memory consumption and improves throughput without sacrificing performance. This approach opens up new avenues for deploying efficient large language models in real-world applications. Future work includes designing more efficient training methods and verifying the model on larger, more complex LLMs. The code is available at their GitHub repository, http://github.com/winlplckv. That's all for today's deep dive. Like, subscribe, and hit the bell icon so you don't miss our next video. Thanks for watching Arxflix. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.